Right. Let's look at an example now of designing a histogram roundup data set. Now, there's going to be two separate videos with this example. The first one is pretty much doing everything by hand. That includes sketching the histogram at the end. Um, but then the second video will be doing this with the Texas Instruments and the NumWorks calculator. So first, let's dive into the first part where we're doing a lot of this by hand. Now, some of this I've kind of filled in ahead of time in the interest of speed. So, this will help you just kind of to follow along and maybe annotate what you see going on. So here we're looking at an example of the weight of tar in milligrams in a sample of non-filtered cigarettes. So the following data represents the amount of tar in milligrams in a sample of 25 various non-filtered cigarettes from a competitor company. So here we have this random variable x, and it's equal to this data set. And these are the individual datums. To kind of give you an idea of what this looks like, I created a dot plot of this data set. So you see we've got, it looks like we have this one little data point out here at 11, and the rest, we kind of have this high point, and then the amount of milligrams of tar seems to be kind of going down as the amount of tar goes up. So step 0 is to enter the datums into your calculator or spreadsheet software. So here's how you can do it with the Texas Instruments. I'll be doing it slightly different than what I've got here. The NumWorks calculator, you do it in the Statistics app, and this is kind of what it looks like. Or you can do it in Microsoft Excel or Google Sheets. And this is kind of how I set it up here in that spreadsheet software. Part of what I also have, in the designing a histogram steps, step 0 also was to identify the sample size. And here the sample size is 25. So I was told it was 25, or I just could have counted each one of these datums in the data set, and there would be 25 of them. And then the decimal places of accuracy, it's actually 0, because there is no decimal point here in each of these datums, right? So the decimal places of accuracy here is going to be 0 in this example. All right, step 1. So step 1 is to find a starting point for the first class lower bound. So what I'm going to do is I'm going to choose this type of interval setup where the lower bound is included. This is conducive for calculators, where the Texas Instruments and the NumWorks calculators, this is kind of the way that they define their intervals. And so since we're going to be visualizing the histogram with our calculators, this seems like a natural place to start. So our starting point option is going to be this one where the lower bound is included. Therefore, our starting point is going to be equal to the minimum value of our data set. So when we come up here and we look at our data set, this is sorting in ascended order. We can see the minimum is 11. So the starting point is going to be equal to our minimum, which is going to be 11. And we're going to define the intervals for each of our classes this way, with a left bracket and a right parentheses. Please note that if we were going to use Google Sheets, Google Sheets uses defines its intervals where the lower bound is excluded. So we wouldn't be able to use 11. We would have had to have used 10. Okay. All right. So anyway, we've chosen our starting point. Starting point's 11. This is how we're going to identify the intervals for our classes. Let's move on to step 2. So step 2 is to find the range. So the range is equal to the maximum of our data set minus our starting point. Now our starting point, that was from step 1, that's 11. What's the maximum? So if we come up back here to our data set, The maximum value is 28. So we're just going to substitute 28 for the maximum. And so the range is equal to the maximum minus the starting point, which is going to be 17. So now let's move on to step 3. Step 3 is to find the number of classes and the class width. So this is where we start to define histogram number 1 and histogram number 2. So we have one data set, but we're creating two histograms, one with a low number of classes and one with a high number of classes. We need to use two methods, the OpenStax method and Sturge's formula. So to calculate a number of classes, we can use this equation. K1 is equal to the square root of n, and Sturge's formula for creating a second number of classes is 1 plus 3.32 log of n. So now to use each of these formulas, we just need to substitute our value of n, which is the sample size, which was 25. So substitute 25 in for n, and we have k is equal to the square root of 25, which is going to be exactly 5. Now let's go ahead and switch over and let's look at Sturge's formula here. So if we substitute 25 in for n and we put this into the calculator, we're going to get K2. The second number of classes is going to be 5.641. Now the rule is now to round down the lowest k. So between K1 and K2, which is lower, okay, the lowest one is 5. So we're going to round that down to the nearest integer, which is going to be exactly 5. So that kind of worked out really well. Now we round up the highest of the two. And so the highest of the two was this one, and that's 5.641. And so we're going to round that up to 6. So our value, our lowest number of classes is going to be 5, and our highest number of classes is going to be 6. So this is going to be the number of classes in histogram 1, and this is going to be the number of classes in histogram number 2. So now we know how many classes or how many bars are going to be in each histogram, but now we need to figure out what's going to be the width of each class in each histogram. So to do that, we use this formula. So it's K low times W low has to be greater than our range. Our range, I think that was step 2. So this we got in step 2. And so the range was 17. And K low we calculated up above to be 5. So now this becomes an algebraic inequality where now we can just divide both sides by 5. And now the width of the low number of classes needs to be greater than 3.4. 3.4 is 17 divided by 5. Now the rule is we just round this up to the next nearest integer. And remember, we need to kind of do a check. We need to do a check to see if it's greater than or equal to 0.9 or if it's less than 0.9. And in this case, 3.4 is greater than 0.9. So then we're just going to round up to the nearest integer. So we just round that up to 4. So we're kind of good to go here. Now let's calculate the width of each class for our second histogram. So K high ends up being 6. The range is the same at 17. Divide both sides by 6. And these 6's cancel. And 17 divided by 6 is 2.83. 2.83 is definitely greater than 0.9, so we're just going to round up to the nearest integer. And so the width for 6 classes is going to be 3 for each class. So what we've got is for histogram 2, we're going to have 6 classes where each class is 3 wide. And for histogram number 1, we're going to have 5 classes where each class is 4 wide. All right, so let's look at histogram 1, which is going to be 5 classes that are 4 wide. So now we can start setting up our frequency distribution table. And so we've got these 5 columns here: class number, lower class boundary, upper class boundary, midpoint, and frequency. So class number, because we've got 5 classes, we're just going to label this 1, 2, 3, 4, and 5. Now class 1 will have a lower class boundary equal to our starting point. So what was our starting point? That was back here at step 1. And our starting point is 11. Now from lower class boundary to upper class boundary of our first class, that's going to be the lower class boundary plus our width. So our width was 4. So we're going to add 4, and 11 plus 4 is 15. And the lower class boundary of our next class is equal to the upper bound of the previous one. And now we'll add 4. And now the lower bound of the next class will be equal to the upper bound of the last one. And we'll add 4. Gives us 23. So basically what you're doing is you're taking the upper class boundary number and you're just kind of going down diagonally and putting it in there. Adding the width, which is going to be 27. Bring that down. Adding the width, and we got 31. All right. So now we have the lower class bound and we have the upper class bound. And the way that we're defining these intervals is we're putting a left bracket here and a right parentheses there. Left bracket, right parentheses, left bracket, right parentheses, left bracket, right parentheses, left bracket, right parentheses. Okay, now let's go ahead and get midpoints. So there's a couple ways we can get the midpoint. One way to get the midpoint would just be to add these two numbers together and divide by 2. Another way to do it, if it's possible, is just to take our width and divide it by 2. So that's going to be 4 divided by 2, which is 2. And then just take this lower class boundary and add 2 to it. So 11 plus 2 is going to be 13. And hopefully you see that 13 is going to be right here in between 11 and 15. So now if we take 15 and we add 2 to that, that'll give us 17. We take 19, add 2, that gives us 21. We take 23, add 2, that gives us 25. Take 27, add 2, it gives us 29. Okay, so we have our midpoints. And now we need to determine our frequency. Now there's a couple ways you can do it. Let me give you kind of both ways that you can maybe look at this. If you have the datums in your data set sorted in ascending order, as I do here up above, then what we can do is class 1 includes 11, and it goes up to, but not including 15. So 15 would be right here between 11 and 18. So how many datums do we have in class 1? We've got only one, the 11. Now, how about in class 2? That includes 15 and goes up to, but does not include 19. So that's going to be all of these ones. How many do we have there? We've got 1, 2, 3, 4, 5, 6. All right, next we're going to go from including 19 and excluding 23. That's going to be all of these ones. How many of those do we have? Let's see, we've got 2, 4, 6, 8, 10. It's going to be a frequency of 10. We're going to go from including 23 and excluding 27. How many do we have? 1, 2, 3, 4, 5, 6. Frequency of 6. And then our last class, class 5, includes 27 and excludes 31. So how many do we have in that interval? We've got 2. So that's class 5. We've got 2. So let me show. This is one way that you could kind of parse your data set into classes if you had a list of numbers like this. But if you had a dot plot, such as I do, let's maybe divide this up. So our boundaries are going to be at 11, 15, 19, 23, 27, and 31. So this is class 1, class 2, class 3, class 4, 5, and 5. Yeah. All right. So in class 1, it's going to be everything including 11, but excluding 15. How many do we have? We have a frequency of 1, which is what I put here. In class 2, it includes 15, does not include 19. So how many do we have? 1, 2, 3, 4, 5, 6, which is what I put here. In class 3, it includes 19, but does not include 23. So how many do we have? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is the frequency I put there for class 3. For class 4, it includes 23, but excludes 27. How many do we have? 1, 2, 3, 4, 5, 6. So we have 6 in class 4. And then here in class 5, it includes 27 and excludes 31. How many do we have? We have 2 in class 5. So you can see by carefully choosing the starting point, the number of classes, and the width, our histogram is going to include the full range of our data. Okay, that's why choosing the number of classes and rounding up the way we do and calculating the width and rounding up the width the way we do ensures that our histogram is going to cover the range of our data. All right. So let me kind of write this down for myself because I'll need this later. All right. So this kind of stuff, with the exception of the frequencies, we can do some of this in the calculator, but I'll show you that later. Let's just focus on sketching this ourselves. So I'm going to scroll down, kind of past this calculator instruction. and spreadsheet instruction. And now let's focus on creating the second histogram, histogram 2. And histogram 2 has 6 classes that are 3 wide. So here I've already pretty much filled in this frequency distribution table. You can see now instead of having 5 classes, we've got 6 of them, right? And the starting point was 11. But now, instead of adding 4 like we did, now we're going to add 3. And so 11 plus 3 is 14. 14 plus 3 is 17. 17 plus 3 is 20, and so on. And the way that I calculated the midpoints is, remember, we can just take the width and divide it by 2. So it'd be 3 divided by 2, which is 1.5. And if we take the lower class boundary and we add 1.5 to that, we get 12.5. Take 14, add 1.5, and we get 15.5. Okay, so that's where each of those midpoints came from. And now we need to calculate frequency. So remember, we're including the lower bound and excluding the upper bound. Include, exclude, include, exclude, like this. And I apologize for the numbers shifting there. It's just the way Microsoft Word works. All right, so let's count the frequencies. So for class 1, we're going to have a lower bound that includes 11 and excludes 14. All right, so between 11 and 14, we've only got 1. Okay, next, class 2. So that was class 1. Class 2 includes 14 and excludes 17. So actually, that's right there. And so there's actually 0 datums that are between 14 and 17. And then from 17 to 20, not including 20, that would be right there. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And then including 20, but excluding 23, this is going to be what, class 4 now. We've got 1, 2, 3, 4, 5, 6, 7. And then including 23, this is class 5. So including 23, excluding 26, this is class 5. We've got 1, 2, 3, 4, 5, 6. And then our last class, class 6, goes from 26 and excluding 29. That's class 6. And how many do we have? We have 2. Okay, let me write these down for myself. All right. So now we've just completed frequency distribution tables for both histogram 1 and histogram 2. And we've now we're ready to go ahead and sketch our 2 histograms. So let's sketch histogram 1. So what I'm going to do is, because we've got 5 classes, we're going to have 5 midpoints. So I'm going to put 5 marks for 5 midpoints. We've got 1, 2, 3, 4, 5. And I'm kind of doing my best to space them out. This is going to be amount of tar. This is in milligrams. And the midpoints here were 13, 17, 21, 25, and 27. The frequencies I had, the highest frequency went up to 10 in histogram 1. So I think I'll try and go up to 12. So I've got maybe 2, 4, 6, 8, 10, 12. Okay. I can put little sub marks here like that. All right. So class 1 has a midpoint of 13, and this had a frequency of 1. So I'm going to go as high as 1. I should label this frequency. There we go. And so this is going to be the bar for class 1. Class 2 had a frequency of 6. So I'm going to draw 6 across like this, just kind of dashed lines. And I'm going to go up to that line, go up to that line, and then over. Let me go ahead and print the frequencies right above the top here. All right, so this is class 2. Class 3 had a frequency of 10. So I'm going to kind of go over 10 and go up to 10 there. And between these two midpoints, I'm going to go up to 10 here. All right, class 4 also had a frequency of 6. So I can just keep coming over this way. And I'll come up between these two midpoints. And there's my 4th class. And then my 5th class had a frequency of 2. So I'm going to come up to a frequency of 2 like that. And there's my histogram. This is histogram 1, which has 5 classes that are 4 wide. And I think I misprinted. Yes, I misprinted. Hopefully you caught it. This should be 29. Now, how did I catch that? I caught that because if there's a width of 4, each of these midpoints should be 4 apart. And I noticed that I'd put 27 down here instead of 29. And the difference between 25 and 29 should be a difference of 4. Okay, so that's how I caught my mistake. All right, so that's what histogram 1 looks like. So let's sketch now histogram number 2. So instead of having 5 classes, histogram number 2 has 6 classes, so I'll put 6 midpoints. Let's get rid of that. All right, so we've got 1, 2, 3, 4, 5, and 6. And those midpoints were 12.5, 15.5, 18.5, 21.5, 24.5, and 27.5. Notice that each of these have a difference of 3, which is what our width was. Okay, so that looks all right. And let's see, the highest frequency in histogram 2 was 9. But just for the sake of simplicity, I'm just going to go up to 10. So we're going to have 2, 4, 6, 8, 10. So 2, 4, 6, 8, and 10. Again, we're sketching, so it's going to be rough. All right, so class 1 had a frequency of only 1. So here's 1. It's going to look something like that. Class 2 had a frequency of 0, so that's not going to go anywhere. Class 3 had a frequency of 9, so I'm just going to go over from 9, and I'll go up between these two midpoints, and I'll go up between these two midpoints, and this is class 3 with a frequency of 9. Okay, class 4 has a frequency of 7, so that's going to be going across this way. And I'll come up between those two midpoints, come over. That has a frequency of 7. Class 5 has a frequency of 6. Come up between these two midpoints. There we go. And then the last class has a frequency of 2. So I'm going to come across, come over, and that is a frequency of 2. So here is my picture of histogram 2. All right, so now you can, check to see whether these two histograms that we created from the same data set, you can see just a difference of one class. Having 5 classes or 6, the histograms look different from each other, right? And let me go ahead and skip ahead here. This is, graphing these histograms on the 2 calculators. And let's ask ourselves an ethical question. So now we created these 2 histograms, right? Histogram 1, which had 5 classes with a width of 4, and histogram 2, which had 6 classes with a width of 3. These are screenshots from the NumWorks calculator, but this is comparable to what we just sketched. Histogram 1 is nice because it looks symmetrical and it's bell-shaped, right? This is a nice looking symmetrical distribution, which is typically desired. But remember what our data looks like. Remember what I said, our data has this one little point out to the side, and then it looks like it has this maximum and slowly tapers down to this higher number of tar, weight of tar. And so when you look at histogram 2, it has this one class way out here to the side with this mode, this higher class here, class 3, and then slowly tapering down as we get to higher amounts of tar. So if I was ethically going to try and choose a histogram that represents my data, I'm not going to choose this one, even though it looks nicer. This one is truer to the data that we have. So does 1 or 2 represent your data? Histogram number 2 represents our data best. So therefore, histogram number 2 is the histogram we use or publish. It's not about trying to support your conclusion. It's about finding out what the truth of the data is and letting that lead you to a conclusion. Okay, so you don't want to have a predefined conclusion. You want to see what the data is indicating. All right, so that's kind of the end of this example, and we've kind of gone through it all by hand. The next video, I'll fill in the gaps, but using a calculator instead. Let me know if you have any questions.